Do you need more? You good? Find the right pencil. Do you want some more graph paper or you good? Okay. So we should just do an XY axis again. And then what we'll do is we'll take a look at what is the matrix that will take a polygon and reflect it. And then the question is, reflect it over what? And we can reflect it over all kinds of things. You know, you can like reflect it over the x-axis or the y-axis, and then there's some other reflections that they're traditionally going to show us with matrices that we can do. So, yeah, I guess, how do we have to, we're going to start with some kind of a shape that has different vertices. And we need to write out, again, the matrix that those vertices are made from, so to speak. Wonder if this thing works. I mean, we can start with it. That way, maybe Nick or Logan, if he's looking at it, and get this. So. And no, we're not going to go back and do all the proofs with between this and collinearity and angle measurement and all that. That's actually what geometry is doing in the afternoon right now. You know all that exists. So if I was to have something like this, I want to leave room for a matrix to multiply by whatever this particular matrix is. So just like what we did yesterday. And then maybe leave some room to where you can write what the image is going to be. So the pre-image and image. And then this is going to be the matrix that we use for multiplying and turning it into a reflection. So you guys get that in there. Did you see your work was in the hallway? So there's 5 theorems in this lesson. But what we'll do is I think we'll intuitively figure out what constitutes each of those theorems. So, come up with some kind of simple design, and then come up with what its pre-image matrix would be. Remember, it's x, these are the x values, these are the y values, right? And how can we reflect it? What are lines that we could obviously reflect this image over? Yep, the x or the y-axis, you could flip it over those. What's another one that you maybe remember from geometry that we reflected things over? Going over the origin, and then we called that a rotation. So that'll come along eventually, maybe Monday or so we'll do that. Today's kind of short. The y equals x line. That's one that I want to make sure we kind of make sure that we remember we can reflect it over that line, because we will be working with that after break when we work with inverses of equations. So like in the past with your algebra, we've done inverse operations on equations, like, you know, when you have 2x, you can divide by 2 to get x alone. Those are inverse operations on an equation, but you can write an actual inverse equation, which basically means that if you take a number and you put it into a function and you get an answer, there's another equation that you can take the answer and put it into that takes you back to the original number. So it's more complex than just, you know, dividing instead of, you know, to undo the multiplication, or subtracting to undo addition. And when we do that, so when we do those types of operations with equations, the equation graph gets reflected over this line. So here's the y equals x line. So let's, even though the reflection over the y and the x lines are a little bit more straightforward, let's go and reflect over y equals x. So if we did that, what happens to the b value on my graph? It stays the same, yeah, it just sits there. What happens to the d value? Where does it end up? Goes to here, yeah? That becomes d prime, because we're reflecting, which means that it is the same distance away from the line of reflection, and it's at a 90-degree angle when we think of this point and its corresponding location. You know, we did all that kind of stuff in geometry last year with, you know, proofs and theorems and things. What happens to the a value for me? It goes where? Flips over to this side of that line of reflection. So if you look at the d value here, this for mine, this starts out as the point 2, 1. What's d prime? 1, 2. So there's the x and the y value. Here's the x and the y value. So what happens to the x and the y values? They just switch. So a is going to end, it starts out up here as, what is that, that's 1, 4. So it's going to become 4, 1. So it's going to end up down here. So look at this matrix here. This value, this row right here, these, don't do that. These two values here are going to get multiplied by this. And then they're going to get added together to equal this. So let's say I've got 1, 4, and it becomes 4, 1. So let's just look at this. Let's say that this is the value A. That's the value B. So A is going to get multiplied by 1. B is going to get multiplied by 4. they're going to get added together, and they need to equal 4. So what would be logical for these two values, A and B, so that we can get a 4? A is 0, and B is 1. So if A was equal to 0, and B is equal to 1, that's going to take the y value and change it into an x. And then if we say 0 and 1 times 4 and 4, this b value is going to be 4. If we take 0 and 1 and we multiply it by 5 and 2, the c prime value is going to be 2. And 0 and 1 is going to turn this into 1. So when we have d prime, there's the x value. We said it was going to be equal to 1, and it came out, so we're on the right track. So what do you think the rest of the matrix is going to look like? 1 and 0. So if you take 1 and multiply it by 1, and 0 times 4, this becomes a 1. And this becomes a 4. And this becomes a 5. And this becomes a 2. So what we've done is we've taken all of these x values, 1, 4, 5, and 2, and we switched them to become the y values. And we take all the y values and we switch them to become the x values. So this right here is a reflection over the x equals y. So just like we wrote the other day, what was it, a size change of some number like k. This is a reflection over the x equal y line. And what it does is oh boy, do they even write it like this? I don't know that we need to know it's like that. Yeah, they do. Yeah, they do write it. They do write it this way. Yeah, so what ends up happening is we are taking x's and y's, and we're mapping it to y comma x. So this is the notation here, the mapping notation. Write this more clean. So take your polygon and reflect it. And while you do that, I'll walk to the middle school and back and see if I can find it passed off. They aren't there. So you got it?
Yeah.
You want to color it? And then, do you think you can come up with what a reflection matrix would be over the x and over the y-axis? Or should we talk? We should talk that one through. Make sure that we don't go down the wrong road mistakenly.
So if you use something other than one, could you do a reflection and a side stream all at once?
Yeah, totally. Yeah, so you could, yeah, if you did 2 here, you'd be making you'd be making your image twice as big after you reflected it. Yes, very good. So I think, like in your notes, it would be advantageous to write down what the different matrices are. You know, like what's the standard form for a size change matrix? What's the standard form for reflection over the y equals x line, over the x-axis, the y-axis? And if you put yourself together just like a cheat sheet of just what the matrices are in one location in your notebook, that's going to be of advantage to you. Because when we come back in January, it's going to get really, really involved with matrices. Because we're going to teach you how to solve systems with matrices. And that's when they become really, really powerful. So these are kind of like, what we're doing right now, these are, I mean, they're cool that you can do it, but they're not algebraically powerful, they're just geometrically powerful. So, what if we're going to reflect it over the x-axis? So if we just start out with what I have up here to try to get an idea of where it has to move and what happens to the coordinates. We're supposed to do those for a while.
You would need, wouldn't it be -1 because you want to make the y's negative?
Yeah, you want to make the y's negative now, right? Yeah, so it gets back to that whole idea of when you're talking about a horizontal axis and something that's oriented to it, we need to change the y value. And so that D is going to reflect down to here. So it's still going to have the same left-right component. It's still going to have the same x value, but the y value is going to be its opposite. So let's...
So you would make the This is over the x or the y axis?
Yeah, so this is gonna be reflection over the x. Up here, we've got reflection over the y equals x. So reflection over the x-axis.
It would be 0, -1, 1, 0.
Well, if we put a -1 here, not only will this configuration reflect it over the y equals x, but then that would reflect it down over the x-axis.
Isn't that what we're trying to do?
No, we're just gonna take this and just flip it over the x. We're just gonna take that and drop it down here.
Oh, okay.
A single reflection, not over two lines, just one. So what would be the matrix to get the same thing back? 1, 0, 0, 1. So if you have this right here, this is called the identity matrix. It gives you back exactly what you started with. But we want to change and make the y value its opposite. So is it the first row or the second row that acts on the y value or the y coordinate? It's the second one. So remember, you know, like if we did this, 1, 4. So if we took these two and multiplied, we would take that 1 and multiply it by the x, the 0 times the 4, and add them together, and then you get this x coordinate. And those we want to stay the same. We want that to stay the same all the way across. What we want to change is the y, and when we take 0 times 1 and 1 times 4, if we were doing a -1, that would turn this sum into -4. And then the 0 times the top 4, the -1 times that becomes a -4, and so on. So this is how we reflect over the x. And we would write that reflection over the x, oops, got the arrow too early, of x and y is going to map to x and the opposite of y. So you could take, since this is all reflections, you know, like you have here the matrix for that work. Now you want to take this and reflect it down here, and you can show the matrix for that work. So this sheet can become your cheat sheet also. You could have, you know, it would be like all of your examples, all of your notes for the entire lesson. You did a rotation. Oh, no, you didn't, because it was here and you were so far away. Yeah, okay, no, not at all, no problem. Just take a look at Lois real quick if you have it. See how, where she drew her polygon and went over the line, so. What does yours look like? You did the same thing. So based on where you started, it was different, which is just fine, it's all good. Yours did the same thing too, right? You put a polygon back in there. So why don't you take your polygon and reflect it over the x-axis in much the same way. From that much information up on the board, can you come up with what a reflection over the y is going to look like? What would this matrix be?
-1, 0, 0, 1.
-1, 0?
Are you taking the A prime or just A going
Yeah, take your original
Okay.
pre-image, yeah, don't keep reflecting over and over and over. I think that'd be confusing to look at. So go back to your original image, then reflect that over the x. So you're going to end up with, when you're all done, you're going to have 3 different images up here. And this one's going to be written very much the same way. But when you're reflecting over the y-axis, you're changing the x to its opposite value.
Now it's A double prime.
Yeah, if you want to call it a double prime, if you can get that formal with it, yes, you can. The most important thing is that you know what the matrices end up looking like. And these 2x2s, knowing those matrices, that's the most important thing here. And having them tucked away somewhere as notes, that if I have to take and reflect over the y equals x line, this is what I use. This is the reflection over the x, this is the reflection over the y-axis. You have that information and you're golden for this lesson. Oh, yeah. They do one more, but I'll let you guys work with this. The last one that they do is not as critical. It's pretty perfunctory. Plus, we're out of here in a couple minutes, right? I heard wire print, and I didn't see a piece of paper come out.
Okay, that's kind of the same. You might just need a refresh, turn off, and they're done.
Yeah, this one does well with that.
Oh yeah, the network connection is solid, should be blinking.
Oh, it should be flashing, but it's talking back and forth.
Yeah. So, I'm just gonna reboot it, is that okay with you?
Yeah, I'm not using it, I'm just hanging out. So, finish those up, and we're golden.